Hello, class. We are on day 3 of complex numbers, at least video 3. I am going to jump on over to page 5 of our packet for complex numbers. The pages before that were homework, so you should have finished those by now and taken the quiz on that little section. So I am on page 5. And so we had been talking about pure imaginary numbers before. And today we're going to jump into really what complex numbers are. And so at the beginning of the packet on page 5, it talks about complex numbers. And so it shows us 5 plus 2i. And so you'll notice that this piece has more information than what we were doing earlier. It actually has a real number. So 5 here is a real number. And then it's attached through addition or subtraction. It could be attached through addition or subtraction right here to an imaginary number. And so when this happens, when we have a real number plus or minus an imaginary number, this is called a complex number. Okay, and we're going to treat complex numbers a little bit like polynomials. And so before break, we had talked about adding and subtracting and multiplying polynomials, something like 2x plus 5 times 3x minus 8, things like that. And so we're going to take these complex numbers and start using the same properties we have learned. We'll notice a little bit of things that are different because we are using imaginary numbers. But for the most part, the rules are the same. And so that's the good part. So on the first part of the section on our notes, it says adding and subtracting complex numbers. Adding is the easiest because adding, let's look at number 1. We have negative 11 plus 3i plus 9 plus 2i. And so with addition, right here I've got addition between two complex numbers. With addition, we can pretend that there's an imaginary 1 here if you want. And so anything that's on the outside of a parenthesis, we're supposed to distribute. But if I distribute a positive 1 into this second parenthesis, nothing's going to change because 1 times itself is the same thing, right? And so what's nice about addition is you really don't have to distribute. You can actually just start combining like terms. And so remember, this is addition. So we're going to take everything as it is. So we're going to say negative 11 plus 9. So that will give me a negative 2. We're then going to take the imaginary part and add those together. So we have a 3i plus a 2i. And so that's going to give me a 5i. So we're going to add the real numbers with the real numbers and the imaginary with the imaginary. And that will give us another complex number, but this is our final answer. Negative 2 plus 5i. Now, what I did mention or didn't mention earlier is that we like to write these in standard form. And standard form means that the real number comes first. And so if you ever see a plus bi, that just means that this a is the real part, and then this 5 is the one with the I. And so we always write it that way if we want standard form. Okay? So addition is super, super easy. You're just combining the real with the real and the imaginary with the imaginary. Okay? Subtraction is a little different. Subtraction, we do have to distribute that negative, and so it will change on us. So let's look at number 3. So number 3 says 7 minus 2i minus 2 plus 6i. And so remember, this is now like saying we have a negative 1 here. If I distribute that negative 1, it does change my second parenthesis. So my first parenthesis will stay the same, but then here I have negative 1 times 2. That'll be a negative 2. And then I have negative 1 times 6i. That'll be a negative 6i. So I just replaced all this with this piece down here. Now I can combine the real with the real and the imaginary with the imaginary. And so I have 7 minus 2, so that gives me 5. And then I have a negative 2i and a negative 6i. That'll give me a negative 8i. And so that is my final answer for subtraction. Okay. All right. Go ahead and try a couple on your own. You can pause the video and try a couple of those on your own. I am going to move on to multiplication though right now. So the third part of page 5 is multiplication. Now number 5, for example, is a lot easier than some of the other ones because number 5 has a pure imaginary, which is 2i, times a complex, which is 8 minus 3i in this case. And so what's easier about this is I just have to distribute that 2i into the parenthesis. So it's a little easier. I can do 2i times 8, so that gives me 16i. And then I could do 2i times a negative 3i. That's going to give me a negative 6i squared. And when we're multiplying and we end up with an I squared, we need to remember that this I squared can be replaced with that negative 1. And that's from the previous video. So if you need to go back and look at that. Okay. So now that that's a negative 1, we have a negative 6 times a negative 1 right here. And that is now a real number. And so the real number, remember, goes in front. So negative 6 times negative 1 will be a positive 6. And then the imaginary part, there's nothing else to combine. And so we would just do plus 16i. And so for number 5, this would be your final answer. So not too bad when we have a pure imaginary being multiplied by a complex. What's more complex is when we have a complex times a complex number. So let's look at that. That's a little trickier. And so there, like number 7, we want to recall that when we're multiplying a complex times a complex, it's like doing a polynomial times a polynomial. You need to remember FOIL. Okay, some other teachers call it the box method, or others just talked about distributing 4 times. Okay, whichever works for you. So in this case, we have 7 plus I times 4 minus I. Okay, so this is number 7. What we need to do is we need to make sure that this 7 gets multiplied to both of the numbers in the other parenthesis. And then we need to make sure that this I also gets distributed to both of the other and to the other parenthesis. So that's 4 different multiplications that you're doing, okay? And so we're going to do 7 times 4 first, and that's where FOIL comes in. You can follow the acronym FOIL, which is first, outer, inner, and last, if that helps you. Or you can just know that you need to multiply all 4 of these, okay? So 7 times 4 gives me the 28. Then I have 7 times a negative I. That's going to give me a negative 7i. And then I'm going to have I times 4. So that gives me a positive 4i. And then the last one is I times negative I. That gives me a negative I squared. Okay? So again, as soon as you see that I squared, you should be thinking I squared is replaced with negative 1. Okay? And so since I squared is negative 1, but we already had a negative here, and then a negative here, we actually get a plus 1. So now that's a real number. We're going to take a real number plus the other real number. And so we have 28 plus 21, so we're going to get 29. And then we're going to combine the imaginary part. So we have negative 7i plus 4i. And so that gives me a negative 3i. And that's my final answer. So very important that you replace that I squared because it's going to simplify down, okay, and change into a real number. The last one I'm going to do with you for practice is number 10 because number 10 has a multiplication and a subtraction in it at the same time. And so it's just a little bit more steps, but it's not too bad. So number 10 will be the last one I do. We have 1 plus 7i times 9 plus 3i. And then we have minus 4 plus 2i. You want to do the multiplication first. So we want to do this piece first and kind of ignore the other piece for now. So we're going to multiply this. And remember, we need to distribute 4 times. So we need the 1 to go to both of these and the 7i to go to both of these. Okay? So let's go ahead and get started. We have 1 times 9, so that's 9. We have 1 times 3i, so that's 3i. We then have 7i times 9i, so that gives me a positive 63i. And then we have 7i times 3i, that gives me a positive 21i squared. Let's clean this up a little bit. So the I squared should be the first thing that came to mind. We're going to change that to a negative 1, which then makes this 21 times a negative 1, which will give me a negative 21. Okay. We have a negative 21 being combined with a positive 9. So we're going to get a negative 12. And then we have 3i plus 63i, so that's 66i. And so that would have been the end if we only had multiplication. But up top, we also had a subtraction going on. And so again, with subtraction, you need to remember that there's a negative 1 here. And so I have to distribute that negative 1 into both of these. So that's saying now negative 1 times 4, so that's a negative 4. And negative 1 times a 2i is going to be a negative 2i. I can now combine those with what I have below. So I'm going to have a negative 12 and minus 4 more gives me a negative 16. And then I have 66i minus 2i. That's going to still be a positive. It's going to be a 64i. And so this is my final answer to number 10. So yes, a little longer, a few more steps, but if you do it piece by piece, it's not too bad. So go ahead and start your homework 5. The other thing I want you to do, what we did in class today if you weren't here, was on page 7, you're supposed to try and fill out the Venn diagram on your own. Based off old notes or Google searches or having a friend help out. And then also there's vocabulary at the top of page 8. I also wanted you to fill that out before next class. So if you missed class, please do that. And then we will have a quiz on these two on the next class period. All right, I'll talk to you later.